Hi, this is T.H. Culhane for Solar Cities, and I have a technique that was suggested to me in a video conference with Taha Majid, the wonderful biogas engineer from Baghdad who's up in Turkey, and he's been following our work here at Solar Cities, and he said to try to heat this IBC digester instead of using these PEX coils and our solar hot water heater, and I'll show you that over here. What we were trying to do, we made a solar hot water system out of Firestone black rubber hose. We had 3 Firestone hoses, each about 25 feet in length, coiled up in a box, and we put 2 layers of stretch wrap as the insulator, and then a bucket on top that gets rid of the bubbles and creates a head of pressure so that we don't have any bubbles in the system. And it worked great when there was a lot of sun, but it's the winter time and it's cloudy. So we also had these 3 photovoltaic panels, each 100 watts, and one of them is charging the battery for the Arduino microcontrollers that are doing the data logging of our tanks. And then 2 others were running the 12-volt pump, 50-watt 12-volt pump that would circulate the hot water when it got to a temperature. There's a probe up in that box. When it reached about 30 degrees Celsius, which is what we want, it would then turn on the pump and circulate the water through the digester and back up to the panel there. And we were slowly heating the tank, but of course that's not going to work in the winter. And a 50-watt pump, it's using a lot of that available energy. So what Taha wrote to us and suggested was, why don't you, instead of using all of this apparatus, since you have the solar panels up there and you're expecting about a 50-watt load, why don't you use a 60-watt 12-volt heating element? I'll show you what that is. And so his suggestion, he was looking on eBay, and it's this. And this is a DC, direct current heating element, like the kind that in many developing countries you see people stick into tea to warm it, or hot water. And originally we were putting it into the charge controller through the battery, but that was draining the battery down because it was assuming a 60-watt load, and then the battery would drain and it would shut off the charge controller over here on the wall, if you can see it over there, this Renogy charge controller. So we were coming out of the load part of the charge controller, and then the battery was being filled, and then it was the solar panels go here and the battery was here, and then the load would come out of here, and then it would shut off automatically. But when the battery was drained, it wouldn't turn back on. So we did that for about a week, and we were getting some heat gain, about 1 degree a day. But as I said, then it wouldn't turn on because the battery was too low, and it would tell the charge controller, don't turn on, don't drain the battery further. So then we wrote to Taha, and he suggested, why don't you just go directly from the solar panel to the DC load. So that's what we did. And there's no positive negative on these things. So we just wired one and the other and went through a switch. We have a toggle switch here. And then up in the top of the tank, you can't see it, but buried under the insulation is a thermostat. And the only one we could get shuts off at 30 degrees, which would be our ideal temperature. Now, good luck getting this tank up to 30 degrees Celsius. But we have that in case when we're gone. The interesting thing is that even though it's a really cold day and the ambient temperature now is, well, it's down about 6-7 degrees Celsius, and it'll drop below 0 tonight. When I touch this, even though it's a cloudy day, it's warm. Now, it's not hot, but it's very cloudy. As you can see if you point the camera up there, there ain't no sun. Ain't no sunshine when she's gone. So the fact that this metal coil is warm to the touch shows that even when the solar panels are maybe producing 5%, maybe they're only producing 5-10 watts, you're still getting heat gain, which will be transferred into the tank. And of course, when you come in sunny, then you burn yourself when you touch this. It does get up to that full 60 watts, and it's very hot. And so we had a spill. We had a situation where we hadn't glued this component to here. What we've done is this goes on the IBC tank. It's a coupling that they sell for the IBC. You could use just a threaded coupling if you have a threaded bottom part to the IBC down there. Ours doesn't. Ours is a special tank that needs this extra mount on it. But then we've got a female threaded 2-inch adapter that's screwed on there, and then we've got a 2-inch to 1-inch bushing, and the heating elements threads were 1 inch. So we were able to just do that, and it fits in perfectly, as you can see here. And then this gets hooked on down here. I've also got a little temperature sensor that I've put here, a little temperature probe that I duct tape on there so I can tell if it's on. Yeah, then this thing just hooks on down here like this, and it will then, as the cold water goes in here and under, then it'll heat up, and by thermosiphon, by convection, the hot water will travel up and allow more cold water to come down into this cavity here. It's not perhaps the most efficient way to do it. It'd be a lot nicer maybe if we stuck this heating element directly into the tank through a uniseal, but then you have to penetrate the tank and you have the problems with possible leakage and crackage and things like that. We want to avoid that, so we're just going in, as Taha suggested, right through the valve here and opening the valve, because all these tanks have these valves. As I'll show you, this one doesn't have threads on it, so we have to use this adapter. Yours might have threads, and all you'd need is this piece, in which case you would use a bit of extender PVC in between here and here if you didn't have that. So do try this at home. We'd love to hear your results. Our next thought is we might want to use a 300 watt, because they don't sell them, but the 60 watt DC and 300 watt, nothing seems to be in between. But if you had a 300 watt element, then even if you had less than 300 watts, it would still heat up to whatever that wattage is. That's the thing that's interesting about these heating coils, and we're seeing that today on a cloudy day. This is a 60 watt, but we're getting some heat because probably producing 5 or 10 watts. So why not use a 300 watt and then keep adding solar panels? Eventually you'll get the thing up to 300 watts and really heat this thing up fast. But while it's not getting up to that wattage, you can still use a 100 watt panel, a 200 watt panel, and put that heat into your tank. This is what we call a heat dump. And they do this for windmills. And in the DC world, when you're running a renewable energy system and you have a windmill, after you've charged your battery, a lot of people will put these heating coils onto the DC load of the windmill so that as the wind keeps blowing and your battery bank is full, it dumps the heat into a source of water. And some people actually use that to heat their water. So they're charging their batteries with their wind generator and they're heating water. And it's similar here. So we're heating water with the excess electrons that are being produced. So yeah, we're going to glue this on. That was the problem. We had this big spill, is that I didn't glue this because I wanted to be able to manipulate it and test it and pull it out and see how warm it was. And the pressure eventually popped that out and we got this big spill. But it works. We're really proud to say, and we'd love to get your feedback on this. Thanks a lot.